In this video, we're going to go over the electronics going on behind the guitar pedal and take a look at modeling the guitar electronics in LT-Spice. This way we can see what frequency responses look like before the sound hits the pedal and maybe get some ideas on adjusting the electronics found within your guitar or bass. So let's begin with this simple example, the Fender P Bass. When it comes to guitar electronics, there really isn't much there, so this is a good place to start. I'm going to use my Glarry GP bass as an example, as I own one and wasn't really bothered by tearing it apart and putting it back together. All we have here is just one pickup and one volume knob and one tone knob. Pretty basic. Let's take a look. So first up, we have a voltage supply that we've grounded here. This is going to represent our actual string that hits the pickup. So if I right click on it here and take a look at the AC analysis for small signal, I have it set to 0.2. Now we have the actual pickup itself, which is really three components when we're looking at it from a simulating perspective. We have the inductor, the resistance, and we have the capacitance that this pickup has built into it. So for the resistance, you can typically get that from the manufacturer of the pickup pretty easily. That's usually listed on the website you're purchasing them from. And in my case, the Glarry P Bass pickup has a resistance of around 10K. Then we have the inductance. This one's not usually as easily found, but if you ask the pickup manufacturer nicely, I'm sure they'll get it to you. In this case, I was actually able to measure mine, and it came out to around 4.4 henries. The pickup capacitance, this one is kind of hard to measure, but it can be done. It typically comes out to being around 120 picofarad. And this is kind of across the board. Now we have our tone pot, which in the P Bass is a 250K pot, which then goes down, which is actually used as a variable resistor. You'll notice that only two legs on the pot are being used. And then that goes to a tone capacitor, which in the P Bass is a 47 nanofarad capacitor. This then leaves over here to our volume pot, which again is a 250K potentiometer. And we lay this out just like we do with our guitar pedals, where max volume would have this as something like, 0 ohms, and then this would be set to 100K if it was a guitar pedal typically, but in this case it'll be 250K because it's a 250K volume pot. Now this right here leaves the guitar jack, and we still have one more thing to consider, and that's the actual cable itself has capacitance on it. Depending on the length and depending on the material and how it was manufactured, an average 10-foot Joe Schmo cable is going to be about 500 picofarad. And then this goes into our guitar amp or into our guitar pedal, and this is the input impedance of that amp or pedal. This is why it's important to make sure that you have the input impedance set to something like 1 megohm, because it's going to be measured here when we do this kind of stuff. If you had something like, say, a fuzz face with a very low input impedance, you'll need to change this value accordingly. So let's take a look at this and model it out. Right at the moment, we have the volume knob set to max, and we're going to see what the sweep on the tone pot looks like. So if I go to simulate and go to run, and if we have our edit simulation command, we have the AC analysis set to decade, number of points per decade is 101, start frequency is at 1 hertz, stop frequency is at 33K. So if we go here and we probe what's going out of the guitar cable going into the amp or pedal that's at the end of this chain, and I'm going to right click here and remove the phase. This is what the potentiometer is doing for the tone pot. So as you notice, as the tone is maxed, that is to say where it's at its brightest sounding, that's closer to here. And you can see a lot of these frequencies are all bunched up. But as the frequencies are dropped due to the tone pot getting set closer to off, that's when we see that the frequencies start to cut at a very low frequency here, which appears to be somewhere around 450 and 500 hertz, wherever you want to call that. Okay, so now if we hard set the tone pot to 250K, that is to say set it to bright, and then comment out my step command down here by putting a semicolon behind it. Now let's actually look at the volume sweep. So I'm going to unhard set my volume knob to max by putting that semicolon there, and then turn on the step so we can go through potentiometer here. So now if I run the simulation, this is the sweep of the volume knob. So because this is a passive pickup, not an active pickup, everything's going to be in the negative dB, so we're just cutting and cutting and cutting. But what you'll notice is, with the volume set to max, we get this little bit of a bump that's right here. However, with the volume being reduced, you notice that the bump starts to slide more and more into the treble. Now, I'm kind of exaggerating here how I'm slanting the cursor, but suffice it to say, there still is a bit of a unevenness here as the volume goes down on this kind of a pickup. So when the volume knob is getting close to nothing, we're starting to see more and more treble coming in, as opposed to when we have the volume knob at full blast. So, what can we do about that? This is where some people will put in a treble bleed capacitor here on the actual volume knob. So we're going to put that right here and wire it up so that it's in parallel with the first half of the potentiometer. And then we'll set the value to something like 460 or 470 picofarad. Now if we redo the simulation, you'll notice that we get a bit of a bump now on the treble frequencies, but the bump is more aligned with itself as opposed to being super slanted. And you can change the value. If you change it to something really high, like 1 nanofarad, you'll notice that the bump moves a little bit further back, closer to 1 kilohertz, and so on and so forth. But in this case, I don't have that on my pickup setup, so we're going to just take that out and reset the simulator. So this right here is what would be good for our P Bass type simulation, but you could also use this for pretty much any single coil pickup setup. So if this was like, say, for a neck pickup on a Fender Stratocaster, and I'm saying neck because there's no tone control on Fender Stratocasters on the bridge pickup, which, unless you deliberately add one, so we'll use the neck pickup as the example here. But if I wanted to make this a Fender Stratocaster neck pickup, we could set the pickup coil down to 2.2 Henrys, which is about where Fender has their pickup set for across the board, really, for the bridge, the middle, and the neck pickup. And the resistance, we could set that down to, I think I've seen neck pickups at around 5.6, 5.8K on Fender Strats. And then the pickup capacitance will still be 120 picofarad. The tone knob on Fender Stratocasters are still 250K, and the tone capacitor on a Fender Strat, I believe, are 22 nanofarads. At least that's what I got on mine. And so you could use that as your simulation for the tone pot. The volume knob and the cable and the pedal or amp that it goes into next would all still be the same. If you're using something that's more like a P90, then you want to increase the coil inductance probably closer to 4 Henry. Again, check with the manufacturer. The pickup resistance, I've seen those at around 8K. Again, though, check with the pickup manufacturer. And the pickup capacitance will still be 120 picofarad. Now, on P90 style guitars, typically Gibson's usually the ones that are called out for that. So for a Gibson type setup, you'll probably want to increase the tone knob to 500K and the volume knob up to 500K to do the proper simulation there. The cable capacitance will still be the same, and the input impedance of the next device should still be the same. So that's how you can do a simulation for basically single coil pickup setups for guitars or bass. Now let's take a look at a humbucker real quick. So humbuckers function a little bit differently with how you model them. The idea is when you look at the statistics, they'll be similar to what we were looking at with single coil pickups. We'll have a single listed inductance, a single listed resistance, and a single listed capacitance. But the thing is it's split up inside based off of the screw piece and the slug piece. So we have two voltage supplies here with 0.2 or 0.2 on the small signal AC amplitude. But we have, like in this case, this is a pickup. This is a Unshaven from Fastback pickups, Fastback guitars. I really like this pickup. It's actually really, really grunty, especially when you're doing down tuning. So I'll put a link to them in the description below. The bridge pickup on mine is about 16K. It's pretty hot. For a passive pickup, it's extremely hot. But because it's close to 16K, You would think that I would have one resistor here that says 16K. I don't. You split that in two. So you would say it's actually 8K on one on the screw and then 8K on the slug. Same thing with the inductance. The inductance was around 6 henries. So in that case, you would have the coil set to 3 on one and 3 on the other. One for the screw, one for the slug. Same thing with the whole capacitance. It's still 120 picofarad like a lot of them, but it's actually broken down into 60 and 60 like so. Now everything after that is the same. So we have our tone pot and then we have our volume pot, both with 500K potentiometers. And for the tone cap, we're using a 22 nanofarad capacitor. And then it goes out to the cable and then into the amp. And if we were to take a look at the simulation right here, we would see that it pretty much works the same way as like you were seeing with the single coil pickup, except for the phase is a lot different. For obvious reason, that phase is what's actually canceling out the 60 cycle hum. But as you can see here, hot pickup, so you notice that the dB is a lot less in the negative than it was on the previous. And here is pretty much a sweep of the tone pot. It's because right here we have the volume set to max, and then it's doing the tone sweep that we saw before. But that right there is pretty much how you would simulate most style of pickups in a system. So that's it for this video. If you like these kind of deep dive videos, press that like button, and if you haven't subscribed, please subscribe. And in the comments below, let us know what kind of pickups that you guys are using, whether it be active or passive, single coil or humbucker, if you got a brand that you like in particular, if you like PAFs or P90s or even those lipstick pickups, let us know in the comments below. And also let us know where you're commenting from as well. If you'd like to support the channel, please visit our website, which is www.diyguitarpedals.com.au, and check out our pedal PCBs and kits, as that would really help us out. Anyways, we'll see you in the next video. Thanks. Cheers.